Hello students, my name is Rahul Singh. I'll be a mathematics instructor for this chapter, that is indefinite integral. Before starting the topic now, let me tell you about the weightage and the importance of this chapter for your board exams, right? So, you know what? That indefinite integral is a part of calculus. And calculus in 12th grade, it covers the weightage of this calculus is 35 marks out of 80 marks in board exams. And calculus is further divided into two parts. One is derivatives, or you can say differential calculus, and second one is integral calculus. Now, derivatives, when we talk about derivatives, it means we are talking about differentiability and continuity and differentiability. And second one is methods of derivatives, and third chapter is applications of derivatives. And these three chapters consist 9 marks out of 35. And now when we talk about integral calculus, then there is indefinite integrals. Let me just rewrite it here. Okay, so when we talk about integral calculus, right, there is indefinite integrals. Next one is, in this chapter we are going to cover indefinite integrals, and then next one there will be definite integrals. Then next one will be applications of integrals. And once we are done with integrals and we are done with derivatives, then the combination of both the things, there is chapter that is differential equation. Differential equation. So differential equation is combination of both derivatives as well as integrals, integration. Now let me just correct it also. It's not 9 marks, it's 13 marks, because if we combine AOD in this also, now, so it is 9 plus 4, so that is 13. And then if we talk about these four chapters, they consist they consist 22 marks out of 35. So out of 80 marks, if you are good in integrals, then only you can get these 22 marks. So now I think now you are having idea that how much this chapter is important for us. That is indefinite integrals. Okay, because if you are good in indefinite integrals, then only you can do better in definite integrals. You can just solve questions from applications of integrals, and it's a combination of both derivatives and integration. So you should know integration if you want to solve question from this chapter. Okay, so indefinite integrals for board purposes, it is very important, and for JEE mains and advanced also, this chapter is going to be very important for you guys. Though we are covering just board level lectures in this series, right? But sometimes whenever required, I'll just let you know few topics that are going to be helpful for a JEE mains and advanced preparation if you are doing that. Otherwise, for board, it will be more than enough. Okay, so let's start the chapter indefinite integrals. Indefinite integrals, right? So if you try to just break down the name of the chapter, right? Indefinite and integrals. So what do you mean by integrals? First thing is, right, and then indefinite means that it's not finite, right? Something which is not finite. So we'll come to that later, but right now if we talk about integrals, right, then integrals is nothing but, in simple words, I can tell you that it is the if we talk about integrals now, so integrals we are going to do in this chapter, we are going to find integration. We are going to do integration. And integration means, well, if we talk about definition, then integration is, it is the reverse process of differentiation. Differentiation. Okay. So with the help of integrations, we are going to find out integrals. Integration is a process, and the answer we are getting using this process, that is known as integrals. Okay. And what is integration? Integration is nothing but it is the reverse process of differentiation. Okay. So for example, let's suppose if I'll ask you that what is the, let's say, what is the derivative of x square? We want to find out derivative of x square. So what's your answer? Your answer will be that derivative of x square is nothing but 2x, using that power rule, right? X power n. Now we are saying that integration is nothing but it's a reverse process of differentiation. It means what? That if I'll integrate 2x, then what should I get? If I'll integrate 2x, then I'll get, you know what? I'll get the same thing, x square. And then we are going to write some arbitrary constant, that is plus c. We'll come to that later, that what is this plus c. But for now, you can just understand that that's how we are going to relate differentiation and integration. So if there is a function f of x, and okay, if there is a derivative of function, and then there is, let's say, capital F of x. Okay, if we are differentiating this f of x, if we are differentiating, so we are getting capital F of x. And if you are integrating capital F of x, then you are going to get the function whose differentiation is f of x. It's like that. Okay. So now, so this is the basic definition of integration. Now talking about what is the geometrical meaning of integration, then let me discuss that also. So geometrical meaning. So if you are, see guys, if you are if I'll ask you that what is the geometrical meaning of finding derivative of a function, so we all know that derivative of any function will give us, let's suppose there is a graph f, or there is a function whose graph is given to us f of x, and if we are finding derivative of this function at some point x equals a, so what we are going to get here, we'll get slope of the tangent at this point x equals a. So this will be, so when we are finding dy over dx, or the derivative of this function, that is f dash of x, then we are going to get slope of tangent of f of x at x equals a, if you substitute a here in place of x, correct? So what is the geometrical meaning of integration then? Integration, guys, remember the difference between integration and integral. Integration is the process to find out integrals. Okay, so integral is the final answer. Integration. Geometrical meaning of integration is that, again, if we are given a function, okay, and let's suppose we are integrating this function. Now in this we need limits, so let's say x equals, so we'll come to each and everything, don't worry. Okay, when we are going to start chapter that is definite integration, in that, during that time now you will get to know what is the meaning of limits and all. X equals b. So integration means what? That if you are integrating this curve f of x from a to b, and the limits are from a to b, it means that you are finding the area under the curve from a to b. So integration helps us to find out area under the curve. Okay, so that's why integration is very, very helpful. So integration means that we are combining things. So we are break in differentiation means what? That we are breaking a thing into small pieces. Integration is the reverse process. It means we are combining things and making it a whole. So if you club all the things from A to B in this graph, so what you're going to get is the area under the curve. And if you're differentiating this function f of x, so we are going to get a point, and basically we are going to get a slope of the curve at that point. That's it. Okay. Now moving forward, so all these definitions we are going to cover. Now, you know what? That integration is also known as antiderivative. Antiderivative. So either you call it antiderivative because it's a reverse process of derivative, no? So that's why antiderivative. Antiderivatives, we can also call it indefinite integral. And antiderivatives are also known as primitives. Okay. So if we are going to, let me just tell you about the symbols and all. So if you see, let's suppose that there is a function f of x. Let me just take this slide. So let's suppose from here we can just, we are given a function f of x and we are differentiating this, we are getting a function g of x. So derivative of f of x is given to us g of x. Okay. It means what? That is there any method to find out f of x if g of x is given? And how did we get g of x? By differentiating f of x, right? Now the question is it possible that from this g of x, can I find f of x? In starting, I told you it's a reverse process. So if you integrate this, we are going to get what? We are going to get f of x. So basically, that g of x we are going to integrate. Okay, we are going to integrate g of x. So and with respect to what? With respect to d of x. With respect to dx. Okay, g of x with respect to dx, it will be equal to what? It will be equal to f of x, and then some constant will write here. Okay, now when I'm writing this symbol, we need to know few things, that this is symbol of integration. Symbol of, so you need to note down these points. Let me write it here. So it means when we are, let's suppose when we are integrating any function with respect to x, and we are getting integral here f of x plus c. So in this some notations are there. Notations are like that this is the symbol of integration. And you can see it is it's like elongated s, right? So symbol of integration. And this small f of x is nothing but it is integrand. Integrand. Okay. Means the function we are going to integrate is known as integrand. So these are the basic terms we all need to know. Okay. Dx means what? Dx means that we are integrating f of x. So f of x is integrand, and we are integrating f of x with respect to what? So that's what we are going to see from here, d of x. So d of x means that integrate f of x with respect to x. So this is going to tell us that with respect to whom we need to integrate the given function. Okay. And this side, this is your final answer. So you can call it antiderivative, or you can call it integral, or you can call it primitive. And this is the constant of integration. I just want you to note down all these things, okay? All these terminologies in the integration chapter. So this is constant of integration. Now this constant of integration, I know that right now you're not getting it, but definitely we are going to come to this topic. You will get to know each and everything. Okay, constant of integration. So I hope that you have noted it. Just pause the video and you can just note it. Okay, going forward. So now we know that what is constant of integration. We don't know that for now, but yes, we know that what is the symbol of integration, what is integrand, what is antiderivative, what is primitive, right? All these things so we know now. So you can see this example. So here you can just figure out the basic difference between derivative and integration. Also, you will get to know you can have clear picture about integration. So this example is like that. Let's suppose we want to differentiate our body. Just it's an you can say hypothetical example here. So we are differentiating our body with respect to x. So basically we are finding d over dx of my body. And I told you that derivative is going to break down anything into small pieces. That is what derivative, right? Differentiation. So if we small pieces means smallest piece, you can smallest unit. So if you are doing differentiation of your body, then we are going to get the smallest unit. And what is the smallest unit of the body? We know it. It's a cell. Correct? So we can say that yes, for sure, if we differentiate our body, we'll get cell. Fine. Now, if you think other way around for this, right? That now we are going to uh, integrate cell, and then what we are going to get as the answer. So now the possibilities are you might think like that if we integrate cell, okay, it means what? That now we are clubbing cells, right? Integrating cell means what? Now we are clubbing number of cells of our body. So it means what? You can say that you will get my body, but this is not 100% sure. Means if you are thinking like that, if we are clubbing cells again, and I told you about the limit also, right? Remember that graph I told you geometrical meaning that when we are integrating anything, we are clubbing all the things under that thing, right? Under the graph, it means we are going to get the area. First thing. Second thing, that it should have limit also. So limit should be defined. Now here, if the limit is not defined, so we can get two cells, we can get three cells, we can get five cells, right? Are you getting the point? So for sure, we are not going to get our body. Means we might get, but it is not 100% sure. So now the possibilities are that we are clubbing the cells of our of my hand only. Means they are just forming my hand. So if we are integrating cells, we are going to get my hand only because the cells may be of my hand, right? And similarly, we can get leg if the cells of leg only, or we can get some other organ of the body. But for sure, we are not going to get that the whole body. So this is the meaning of indefinite here. That indefinite means what? That integral if there is no limit, because limit is not defined. Na? If I'm defining limit here, that I want to integrate cells of my head. So if you club all the cells of the head, then the answer will be head. But right now there is no limit. So if there is no limit, now the final answer can be leg, it can be hand, it can be head, right? So that's why the answers are different. Many answers are there depending upon the limits. So that's why we call it indefinite integral, because we are not going to get single answer. We can have infinitely many answers for the integral. That's why it is indefinite integral. I'll just tell you this by taking one mathematical example. Okay, so when we can't predict that the cell is of my hand or my leg or any organ, then in that case, it is known as indefinite integration. Okay, now let us take one simple example for this. I'm writing it here, and from here we will get to know the meaning of arbitrary constant in integration or constant of integration. I'm defining it here, constant of integration. So constant of integration, right guys? Yes. Okay. Now, constant of integration, let's suppose we can again start with that example. Let's say we want to differentiate x square, find out d over dx of x square, and you all know that it is 2x, correct? Now if you want to find out, okay, fine. Now we are going to integrate this. So how we are going to integrate this? Integrate this means what? That we'll integrate this thing. Yes or no? So if you integrate 2x with respect to x, what we are going to get? Can anyone tell me what we are going to get? What we are going to get is the same thing, that is x square. Yes or no? Yes. Now let me take one more example here, d over dx of x square plus 1. And now if you differentiate this x square plus 1, so again we know it that derivative of x square will be 2x and derivative of 1 will be 0 because it's a constant and derivative of constant is 0. We'll all know it, right? So again, if I'll ask you that what is the integration of 2x with respect to x, in this case, because we have differentiated x square plus 1, then the answer should be x square plus 1. Let us take one more example. Now, I hope that you are getting my point. What is the meaning of constant of integration? X square plus 2, let's say, or x square minus 1 also you can take. You can take any constant here. So again, if you differentiate this, so we are going to get 2x only because constant, the derivative of 2 will be 0. So So now, if you integrate 2x again, so what we are going to get here, we are going to get x square plus 2. Integrate 2x with respect to what? X. So dx, we need to write x square plus 2. Now, let us take one more example, d over dx of x square minus 1. So again, derivative of this will be 2x. It means that integration of 2x should be equal to x square minus 1. So now, if you can observe, right, you can see that every time we are integrating 2x only 2x, 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 and we are getting different answers. Here it is x square, then x square plus 1, then x square plus 2, then x square minus 1. So that's why, that we always write constant of integration means if we are integrating any function, let's say we want to integrate 2x dx, then instead of writing all these answers, and now I think you can see that there will be infinite answers, right? We can take any constant with x square and then every time we are going to get different answers. So for 2x, if we are integrating 2x, we are going to get infinite answers. Okay, that's why instead of writing all the answers, we cannot write all the answers, right? It's not possible to write down each and every answer because there are infinite answers. So instead of writing all the answers, we are going to take help of constant of integration, and in that case we'll write that it is nothing but x square plus c. Now this plus c is the constant of integration. This is going to represent everything. It is 0 here in first one, so c can be 0, then 1 2 3. So c is arbitrary constant, means it's a number, right? It's a real number, you can say. So this plus c is representing all the infinite answers for this integration. So that is the role of constant of integration. Now, if you want to understand this constant of integration geometrically, then let me just tell you this also, that let me just show you one more picture so that idea will be clear to you. Constant of integration. Yes. So if we see here, now you can just write down this definition also. The resulting function obtained by indefinite integration represents a family of curves. Actually, that that integration, when we are doing like integration of 2x, it is x square plus c. Now x square plus c is representing family of parabolas because x square, y equals x square will be a parabola, and then it is representing family of parabolas. Okay, because there will be infinite answers, so infinite answers are representing family of the same curve. And if you see that x square minus 1, this is the first graph here. This is x square minus 1, then x square with the yellow color, then sky blue color x square plus 1, and then red color it is x square plus 2. Now for all of these, if you find derivative of any one, at some point. Then at that same point, let's say it is x equals a here. This is x equals a. Now at x equals a, the derivative means the slope of the curve at this point x equals a is same everywhere. This is m, here also it is m and m. Okay, so that's why every time we are getting same answer. For this also it is 2x, for this is also it is 2x, because it is nothing but slope. Slope is m and m is equal to, means all the slopes are same here. So every time we are getting same answer, 2x and 2x and 2x. And in x, if you replace x with a, so we get 2a, 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 2a. Okay, so these are that's why we are getting same answer for derivative, because that for each and every parabola x square plus 2x square plus 1 x square minus 1, uh, we are going to get same slope at x equals a. It means that all are the family of parabolas, and at x equals a, they are having the same slope. And similarly, the same thing is that when we integrate something, we are going to get family of curves. I hope it is clear to everyone. Just pause the video and just copy it. Okay. Now, going forward, let me just. I hope that idea of constant of integration is clear to everyone now. Yes. So now you can just read all these points here. But don't need to no need to read all these points. Just remember whatever I told you about constant of integration. It is more than sufficient. Make that graph also. It is going to geometrically, uh, we are going to get family of curves. We are doing indefinite integration. Okay. Now, if you just read this point, there is no need to introduce any arbitrary constant after calculating each integral. By combining all in arbitrary constant, we get a single arbitrary constant denoted by letter C, which is added to the final answer. It means what? That let's suppose these are the properties of indefinite integration. That let's suppose instead of single integration, we are given three functions or four functions in addition or subtraction, and then we need to integrate all of them, and then we need to find out the answer. So the question is like, let's suppose we need to integrate f of x plus g of x. Okay. So first thing is that we can distribute integration over both the functions. So we can write integration of f of x separately plus integration of g of x separately. First thing. Second thing, that now if you just integrate this thing, let's say we are getting capital F of x. And now here what you are going to write, C1. Because whenever we are doing indefinite integration, always write constant of integration in the final answer. So plus C1, and similarly g of x, capital G of x, integration of this, and plus C2, because there are two different functions, so we are writing C1 and C2. Now you know what, that at the end instead of writing C1 and C2, you should write the final answer like f of x plus g of x, and now we can club these two constant of integration and it will make 1. So we can write plus C only. So even if there are n numbers of different functions are given to you in addition or subtraction, no need to write n numbers of constant of integration. Just write down at the end single constant of integration. Why it is so? That let's suppose C1, it's a numerical value. So C1 can be, let's say, minus 2. C2 can be anything, let's say it is 4. So at the end, if you add these two, we can add these two, no? Because they're like terms. So we can add these two. And if you add these two, it will become 2 only. So C is 2. So that's why we can club all the constant of integration, and at the end we'll write only one constant of integration. Okay. So don't worry, we'll discuss all these things in detail when we will be solving the questions. Now, so these are the basic definitions in starting. I have covered only that the process of finding the indefinite of function is called integration, right? Yes. Yes. Now these are the points that you need to note down, guys. These are the very, very important points. Okay. What is the first point? That what do you think whether we can find integration of every function? No, we can't find. Why? Because first thing is that, you know, what is integration? Integration is the reverse process of differentiation. And can we find differentiation of every function? No, we can't find. Na? when the curve is, when there is having a sharp corner, right, on the graph. At that point we can't find derivative. If the graph is discontinuous, we can't find derivative at that point, right? So sorry. Similarly, we can't find this integration also. So first thing is very very important point, that not every function has integrate. We cannot do integration of each and every function. Okay. So for every function, indefinite integral will not exist. When it will exist, this is also you can just note it, that when a function, any function f of x is continuous in the interval open a to b. First, it should be continuous in the open interval a to b, means that extreme points are not included. But yes, in between a to b, it should be continuous. Means if we try to plot graph, then let's suppose if there is a function something like this. So don't include this point. Let's say it is x equals a. This is x equals b. So in between x equals a and b, it should be continuous. In between x equals b, if it is something like this, okay, and let's say this is x equals a, this is x equals b. In this case, it's not continuous, right? In between a and b. So we cannot say that in a to b, this function is not integrable, but this is integrable. So first thing, so that every function is not integrable. First thing. Second thing is that a function is only integrable when it is continuous in open a to b. Then there exists an indefinite integral in that interval a to b. This is a symbol of integration. I already told you, right? And integration is nothing but it is the reverse or inverse process of differentiation. We know it now. Fine. Constant of integration, the same thing, that if you are finding derivative of x square plus 1 or x square, every time we are going to get 2x. And then if we are integrating 2x, we can get x square plus 1, x square plus 2, x square plus 3. So it is talking about the constant function. So means that any two integrals of the same function, they will be differing by a constant only. That's it. So now let us talk about some basic formulas of integrals, right? Standard formulas of integrals. So first one, I just want you to write down like this, that you should make a table. In that table, you need to do one thing, that make two columns in the table, and in the first column, you need to write down the derivative of a function, so that in this way, you're going to revise the formulas of derivative also, and then also you can relate it with the process of integration, right? So derivative, and this side we are going to write down the formula for integration. Integration. Okay. So we'll first start with this only, guys. So let me just give you, let's suppose if I'll ask you that what is the derivative of x raised to n? Find out d over dx of x raised to n. And all of you know it, that it is nothing but n into x raised to n minus 1. Yes or no? Right? So it means what? That if I'll integrate this now, if I'll integrate this n into x raised to n minus 1 with respect to what? With respect to dx, then what should I get? I should get x raised to n. Correct? X raised to n plus c. Don't forget to write down the constant of integration. Similarly, now let's suppose if I'll ask you to write down, find out d over dx of x raised to n plus 1 over n plus 1. So what you're going to do, first you will take this constant outside 1 upon n plus 1, and then you are going to find out derivative of x raised to n plus 1. And using power rule, we can write n plus 1 power outside into x raised to n plus 1 minus 1, right? And now we know that this will get cancelled out, and we'll get derivative of x raised to n plus 1 over n plus 1 is nothing but it is equal to, this also will get cancelled out and it is equal to x raised to n. Yes or no? It implies that if we integrate x raised to n, so what we are going to get? We are going to get this function, this thing. So right down here, it will be x raised to n plus 1 over n plus 1. So this is the first formula for integration, that if any polynomial expression is given to you or x raised to n is given to you, then the answer for that will be x raised to n plus 1 over n plus 1 plus c. And see guys, we are getting this formula with the help of derivative. And we know the definition of integration, it's a reverse process, so that's why. If the derivative of this function x raised to n plus 1 over n plus 1 is x raised to n, it means what? It implies that the integration of x raised to n will be x raised to n plus 1 over n plus 1. And don't forget to write down the constant plus c. I hope it's clear to everyone. So let us take some example here. So let's suppose, so this is your first formula guys, okay? We're going to write down this in table also. Now, so let's suppose, simple question I'll give you, that what is the, let's suppose what is the integration of x raised to 3. So x raised to 3, correct? So, and we want to integrate this with respect to x. So x raised to 3 with respect to x. Now using the formula, what is the formula? That x raised to n is equal to x raised to n plus 1. It means x raised to 3 plus 1, and 3 plus 1 divided by n plus 1. So 3 plus 1, and don't forget to write down the constant of integration. So it will be x raised to 4 divided by 4 plus c. I hope it's clear to everyone. Yes, guys. Now the same concept we can apply if the power is negative also, or if power is fraction. So let's say, let me take this thing, minus 1 upon 2. We want to integrate x raised to minus 1 upon 2. So again, and you should observe here that when we are writing this function, right? So we can clearly see that for this one, n cannot be equal to minus 1. Means you can apply this formula for any power of x until and unless n is not equal to minus 1. This also you need to make sure. Why n can't be minus 1? Because if n becomes minus 1, then the denominator here will be 0. And then this whole thing will become undefined. So this formula is applicable for any power of x except n equals minus 1. The power cannot be minus 1. I hope it's clear to everyone, guys, right? So clearly, this question, though, we can easily apply the first formula because the power is not minus 1, it is minus 1.2. So it can be a fraction also. N can be any value except minus 1. It can be any real number. Okay. So now using the same thing. So how we are going to write it? That it is nothing but x raised to n plus 1. So minus 1 upon 2 plus 1 divided by minus 1 upon 2 plus 1 and plus constant of integration, because we are writing final answer of integration. No? So if you just simplify the power, so it will become x raised to 1 upon 2 over 1 upon 2 plus c. You can further simplify it also, right? So it will be nothing but it is equal to 2 will go into numerator and then x raised to 1 upon 2 plus. So this is the answer. So that's how you can use the first formula, right? So now I'm going to write down all the formulas directly, and then later on we'll discuss questions based on these formulas. So these are the elementary formulas in integration, right? Basic formulas. Okay. So first formula is that if we want to find derivative of x raised to n plus 1 over n plus 1 with respect to dx, it is nothing but x raised to n. It means what? Sorry guys, let me just write it. We're writing derivative here, so d over dx of this. It means what? You need to remember these formulas. Okay, I'm writing it here. Integration formula. So if we integrate x raised to n with respect to x, it will be x raised to n plus 1 over n plus 1. And don't forget to write constant of integration plus c. So this is your first formula. This is the first formula of integration, right? Then moving forward, if you see next formula in this, is that, and guys, it is means this one is so very easy. Okay, if I'll ask you that what is the derivative of e raised to x, derivative of exponential function, that is e raised to x. Okay, so derivative of e raised to x, everyone knows it, right? That it is e raised to x only. So what should be the integration of e raised to x? Reverse process, correct? So if we integrate e raised to x, we should get what? E raised to x plus c. Very simple. So this is the function where both the things are same. Even if you are finding derivative of e raised to x or you are finding integration of e raised to x, both are same. Okay. Now third one. Third one, let's suppose we want to integrate, we want to find out derivative of a raised to x. Now, so e raised to x is also exponential function, right? A raised to x is exponential function as well, but the only difference is that first tell me guys, what is the derivative of a raised to x? Yes, anyone? What is the derivative of a raised to x? So a raised to x derivative, if you see, it is nothing but a raised to x log a. Don't forget to multiply with log a, right? So it is a raised to x log a. It implies that if I'll integrate, let me just write it here first and then final answer we're going to write in the table. So let's say we are talking about that what my question was, that what should be the integration of a raised to x. This we need to know. It means what? That you should think like that whose differentiation should be a raised to x. In reverse way you need to think. My question is that what is the integration of a raised to x, right? Then you should think about a function whose derivative is e raised to x. So like this, so we can't simply think like this, right? It means we have some method to find that. What is the method? That instead of finding integration, let me first find out derivative of a raised to x. So if you find derivative of a raised to x, then what we are going to get? We are going to get a raised to x into log a. Additionally, we need to multiply with log a. That's it. Fine. So it means what? When we are going to get derivative a raised to x, when I'll take transpose this log a to the left hand side, means that if I'll find derivative of, now you can see guys, take log a this side, so in denominator it will be log a. If you find derivative of this now, so again 1 upon log a, so we can take outside, it's a constant, and derivative of a raised to x will be a raised to x into log a. Now this log a will get cancelled out, and now we are going to get a raised to x. So basically this is the function, and what is the function? A raised to x log a over log a, right? A raised to x over log a. This is the function whose derivative is a raised to x. It means what? That what is the integration of a raised to x? Reverse process. So integration of a raised to x should be this function, this whole function. So it is nothing but a raised to x over log a and plus c. So that's how we can just find out the formula also in reverse way. Okay, whenever you need to find out integration of any function, just think about that whose derivative is this function. That will be the answer. So now, so let me just do some changes here. Instead of writing log a, we'll take log a in denominator, log a. And now, if we integrate, a raised to x, so what we are going to get, guys? We are going to get this whole function, that is a raised to x over log a plus c. So, so now if you will go with the basic definition, then you will find integration very easy. But there shouldn't be any confusion, right? Fine. Now moving forward, next one is that what is the derivative of log x? So guys, when we are writing log x, right? So when we are writing log x, Or let's say the question is like that we want to find out integration of log x. Is it possible to find out integration of log x? Yes, it's possible. But for now, we are talking about basic formulas. So right now, we can't find. With the help of, so in next lecture, we are going to study about the different methods to find out integration. So method of substitution is there, then partial fraction is also there, and then integration of parts. So with the help of all those methods, right now, if I'll ask you that how to find integration of log x dx. Now what means you can just think about a function whose derivative is log x. Yes or no, guys? So can anyone tell me that what's the function whose derivative is log x? Right now, though, you can't find it directly because we know the derivative of log x is 1 upon x. Correct? So don't say the derivative of 1 upon x will be log x. No, so just kidding. But yes, that if I'll ask you directly right now, no, that find out a derivative function whose derivative is log x. You can't answer this right now. So right now I'm not able to find out answer for this question. But yes, there are methods to find it. But now what we are going to do is that if I'll ask you, my question is like that what do you think what is the integration of 1 upon x dx? Now some of you might think about that we can use power rule here, right? So you can write like you can write this like x raised to minus 1 dx. But if you remember guys, in the formula you can just see in table also. Let me write it here. I have not written it here. That n cannot be equal to 1 here. This we need to make sure. I told you, right? N cannot be minus 1. Not 1. It should be. It can't be minus 1. So if you see here, so just n can n cannot be minus 1. So now if you see what is n here, power is minus 1. It means what? That we cannot use power rule here because n is equal to minus 1, so we cannot use power rule here. So then how we can find answer for this question? Yes, we can find it. Now we'll think in terms of differentiation. So now my question is that can you tell me any function whose derivative is 1 upon x? We all know it. What is that? It is log x. It is nothing but log x. So log mod x plus c will be the answer. Means that if you find derivative of log x, derivative of log x, so it is what? It is 1 upon x. Okay. And you know what? Actually, we are finding derivative of log mod x because we know that the domain of log is defined only when the argument is positive. Correct? So x can be any value. So to make it positive, we always take mod. And that's why when we're writing, so now if I'll ask you that what is the integration of this function, reverse process, this is the integration log of mod x. So what is the integration of 1 upon x? It is log of mod x plus c. Why we are writing mod? Because here x can be any value, it can be negative also. But when we're writing final answer in terms of log, x cannot be negative. That's why we need to make sure that it is always positive. So that's why we're taking modulus here. I hope it's clear to everyone. So now just write down this also. Fourth formula is that d over dx of log of mod x is 1 upon x. It implies that you need to, if you want to find out integration of 1 upon x dx, it will be log of mod x plus c. So guys, in maths, remembering the formulas won't help you. Means you need to remember the formulas. First thing, very important that you need to remember all the formulas. So you need to just keep revising these formulas again and again. But only remembering is not going to help you in your exams. So in calculus, in integration, I'll recommend you to practice more and more questions. That is the key to get good marks. Okay, just practice more and more question. So practice more and more question means that on single formula, let's say we talk about first formula only, power rule, right? X raised to n. Practice at least 20-25 questions on this by taking different powers of x. Okay. E raised to x, even though it is very simple, right? E raised to x integration is e raised to x. Still, in upcoming lectures, we are going to see that how difficult question we can get using e raised to x also. So you need to practice at least 20-25 questions on each of these formulas. Then only you are going to revise, you are going to learn and remember all these formulas. Okay? Yes. Then next formula is that integration of cos x. Yes, integration of cos x, guys. So now we are moving to, so first we talked about, we are just distributing all these things. First we talked about polynomial or algebraic integration. Then we discussed about exponential integration, and then we moved on to logarithmic integration, right? Now we are going to talk about the formulas of trigonometry. So if trigonometric functions are given, then how we are going to integrate all of those. Fine. So again, now let's suppose first thing that if I'll ask you, so let's keep it simple only. If I'll ask you what is the derivative of sine x, we all know it. Derivative of sine x is cos x, correct? So then what is the integration of cos x? Integration of cos x, again, the reverse process, guys. This should be the integration, that is sine x. So integration of cos x will be sine x and plus c, correct? Now, what is the next one? What's the derivative of cos x? Derivative of cos x is minus sin x. Remember, minus sin x. So when we are finding derivative of any trigonometric function starting with c, right? Cos, like cos x, cosecant x, cot x, the answers are always negative. Okay. So derivative of cos x is minus sin x. It means what? The derivative of minus cos x will be, it will be the minus into minus sin x. So minus into minus will get cancelled out, or it will be positive. So we get plus sin x only. Is that clear to everyone? It means that if I'll ask you what is the integration of sin x, the answer should be it is minus of cos x plus c. Minus of cos x plus c. What is the derivative of tan x? We talk about tan. So what is the derivative? And we are going to discuss questions based on these formulas right now. So we are writing all the formulas and then we'll solve questions. Don't worry. So what is the derivative of tan x, guys? It is secant square x, right? It means that integration of secant square x will be tan x plus c. Then next one is eighth one. What is the derivative of, let's say, sine, cos, tan is done. We can now start with secant. What is the derivative of secant x? Yes, can anyone tell me? Derivative of sec x. Derivative of sec x is sec x into tan x. Correct? So it implies that integration of sec x into tan x, integration of sec x into tan x will be secant x plus c. Okay, so now all the formulas are given to you in the slides. You can just visit to these slides, right? And you can just write down all the formulas. It's there. Now similarly, you can see integration of minus of cosecant x, right? Why we are taking minus here? Because we know that the integration, sorry, derivative of cosecant x is minus of cosecant x cot x. So that's why initially we are including minus here so that we can find directly integration of cosecant x, and it is minus of cot x plus c. Then inverse functions are there. Now in this, if you see guys, we have found out all the just because we know derivative of sine, cos, tan, cot, secant, cosecant. So we can find integration of what? Integration of derivative of sin x, integration of derivative of minus cos x, that is sin x. Sin x integration is cos x plus c. But in these formulas of trigonometry, right, you can see that we didn't talk about integration of tan x. We didn't talk about integration of you can say cosecant x, integration of cot x, integration of only we talked about two formulas, that is integration of cos x and sin x. What about others? We are not finding integration of secant x. We are finding integration of secant square x. That is tan x plus c. We are not finding integration of cosecant square cosecant x. Instead of that, we are finding integration of cosecant square x. It means what? That there is no integration of secant x? No, it's not like that. Integration of secant x is there, but that we are going to find out in next class, next lecture, when we'll discuss about methods of substitution. Okay, so different methods are there. That's why right now it's not possible for us to find out integration of secant x because we don't know the derivative of secant x right now. Fine. Derivative of means when I'm say that integration of secant x means that we don't know the function whose derivative is secant x. Derivative of secant x, so we know, but we don't know the function whose derivative is secant x, and that we are going to find out with the methods of integration, in which we are going to use substitution method to find it. Don't worry, we'll discuss all of these things in next lecture. Then there are inverse function, right? So far, how we are covering things. First, we discussed about polynomial function x raised to n, how to integrate this. Then we discussed about exponential function, right? E raised to x, then a raised to x, how to integrate these functions. Then we discussed about logarithmic function, what is the derivative of log of mod x, right? Then we discussed about trigonometric functions, and we know that there are six trigonometric functions. So right now we are having six formulas from trigonometry, but means we have not discussed about integration of 10x and all. We'll discuss in next lecture. Now, going forward, if you see that after trigonometry there are inverse trigonometric function, and now I'm not going to write each and everything. You just make note in that table. Just write down all the formula. Integration of, we know that differentiation of sine inverse x, guys. What is the derivative of sine inverse of x? It is 1 upon under root of 1 minus x square. And you know what? This is also derivative of minus of cos inverse x. Sine inverse x derivative is also equal to derivative of minus is also equal to the derivative of minus cos inverse x. Both are same. It means what? That if you integrate this thing, if you integrate this thing, so either you are going to get sine inverse x or you are going to get minus of cos inverse of x. Okay, so we can write this formula as that integration of 1 over under root of 1 minus x square is equal to sine inverse x plus c or minus of cos inverse x plus c. And also these formulas also we are going to find out using methods of substitution, that how we are getting this formula. Or right now, so we can use basic definition, right? That if the derivative of sine inverse x is 1 upon under root of 1 minus x square, then integration of 1 upon square root 1 minus x square will be sine inverse of x plus c or minus of cos inverse x plus c. Similarly, for tan inverse x, 1 upon 1 plus x square, so integration of 1 upon 1 plus x square will be tan inverse x plus c or minus of cot inverse x plus c. Then secant inverse x, so write down all these formulas. Okay, then hyperbolic functions are there. Sine of hx, cos of hx, right? These are the hyperbolic functions. So they are not going to come in your exam, but still you can write it. Okay, then inverse of hyperbolic functions. Now, after this, the important part is few, you can say properties of integration. So what is the first property? Just write down from here. that properties of integration. Properties of integration. Or you can say algebra of integration basically, right? Algebra of algebra of integration. Okay, what is the first property? This is first point. Okay, that if there is a function f of x and it is multiplied with the constant k is a real number, right? So if a function is multiplied by constant and then we are finding integration of this, so either you can do this way or you can take constant of integration outside first and then integrate f of x. Both will be same. So means it's not a big deal. You can just, or if you want me to take some example, I can take that example also. So it's means you can understand this thing right easily. That we can take constant outside from the function and then just integrate the function and multiply constant at the end. The answer will be same. But how you are going to write answer for this question? Let's suppose that integration of f of x dx is capital F of x. So if I'll ask you what is the integration of k into f of x dx, so we can take k outside and then we'll integrate f of x, and now integration of small f of x is capital K of x, capital F of x. So capital F of x just multiply with k and then don't forget to write down the constant of integration and don't multiply this k with c. Okay, this you need to remember in the first property. So any constant we can take outside the function and then integrate the function. Now if there are two functions in addition or subtraction, f of x plus minus g of x, and it can be applied to n number of different functions, and they are in addition or subtraction when we want to integrate them. So either you first add both the function and then integrate, or you can integrate individual function separately and then add or subtract. The answer will be C. Okay, so this is your second property. Third property is this is also covered in second property only, plus or minus, and it can be extended to n number of terms, functions, right? Means if there are two functions in addition or subtraction, the same thing can we can done for the three functions, for four functions, for n number of functions. So that's not an issue, right? So this is the extension of property number two only. In general format, we have written this. We can write this as property number three. Then if f of x and g of x are two integral function and k and n are two real numbers, so I hope that now so it is very much understandable that if a constant is multiplied, k is multiplied with f, l is multiplied with g, we can integrate both the functions separately, and then we can take constant of outside from the function. That's it. Okay. So guys, for today, this was your first lecture in which you have covered the basic introduction about integration, definition of integration, then what is constant of integration, then basic elementary formulas of integration, right? All these things. So now we are good to solve first exercise from NCRT. Okay, so just remember all the formulas and try to solve each and every question. Then we are going to start next topic, that is methods of integration. So I hope you like the session. Okay, don't forget to practice more and more questions. Bye. Thank you.